So the topic is disk free space management, which is the last topic of file system implementation. And there were some questions asked based on this also. There could be a 5 mark question on this. So there is also a star topic. Okay, you can expect a straight away 5 mark question on discussion of disk free space management. This topic implies how are we going to keep track of free space. So for that, let's take some data set. Let us imagine we have got a disk of some size, say 20 MB. Okay, 20 MB disk, very small disk, hypothetical, practically does not exist, only for the purpose of theoretical understanding I am taking this. Let us say this disk is divided into disk blocks of size dbs, disk block size. Earlier we told disk block size is 1 KB. This is divided into blocks, each of size 1 KB. And let us say to address each of those blocks I need 16 bits. 16 bits of address is needed to select one block of size 1 KB. Means practically or conceptually, if you understand, this is the disk size of 20 MB. We are dividing this into blocks of size 1 KB like this. So let's imagine these are the blocks. This first block 0, second block 1, third block 2, 3, like that. These are disk block addresses, disk block numbers. So like that. So each block of size 1 KB. Now the question is, how many blocks are we going to get on the disk? Again, understand the problem. Disk size 20 MB. That disk is divided into blocks of size 1 KB. So how many blocks will I get? Disk size 20 MB divided by blocks of size 1 KB, which is equal to 20K blocks. So this disk will have got 20K blocks. So initially all these blocks will be free. Initially all these 20K blocks are free. So let me write. So all these 20K blocks are free. So how to keep track of these free blocks? Those are called free block algorithms or disk free space management. That is called disk free space management. So how to keep track of disk free space? That is the basic objective of this. There are essentially 3 algorithms for keeping track of free space management. Free space management algorithms. This is the topic of discussion. How to keep track of these 20K free blocks, that is the objective of this. That is the objective of this. So let's see the one by one each of them. So what did we said? We said that initially we have got 20K free blocks. How do we keep track of them? First algorithm is called free list. Free list. That is, we are going to maintain, I am writing down, maintain a linked list. We are going to maintain a linked list, the nodes of which contain addresses of free blocks. I will explain it, just follow me. So that means we are going to have a linked list, is the first node of the linked list. Now this is also one block of disk, because this will also be stored on disk. So anything that gets stored on disk will be in the form of blocks. So what is it going to contain? It is going to hold the addresses of free blocks. So here I will store one address X, Y, P, etc. Okay. Suppose if this gets filled up, then I will take a pointer pointing to another block, another node. So in turn, this is also going to contain the addresses of free blocks. So here also I will have addresses of free blocks. Like that it goes. We are going to have a linked list of blocks containing addresses of free blocks. So this continue. This is called free list. I'm writing in short free list. So for your convenience, again I'm saying here, please. What are these? These are, so here also we'll have something like that. These are, I'm writing it down. All these are addresses of free disk blocks. Let me scroll down. Let us see from here. Okay. These are the addresses of free blocks. Just scroll it. So these are the addresses of free blocks. It's a linked list of blocks. The blocks, you also call it as nodes. Blocks containing addresses of free blocks. So let's work out a simple problem on this. Now, if you remember from my previous page, we said that we have got 20k free blocks, right? All these are free blocks addresses. So how many blocks of the linked list are needed to store all these 20k free disk block addresses? So we can make a simple calculation. The problem goes like this. What is disk block size? Disk block size is 1 KB. What is disk block address? Disk block address is 16 bits. 16 bits means 2 bytes. Is it not? So we will calculate one block which is 1 KB can store how many addresses? Look at that. One disk block address is 2 bytes. Block size 1 KB. So in 1 KB, how many 2 bytes we can store? 1 KB divided by 2 bytes. 1 KB divided by 2 bytes. This will give you 512. This goes 512 times. What is 1 KB? 1024. So 1024 if I divide by 2 become 512. So one block can store 512 addresses. How many addresses we have? 20k. So 20k need how many blocks? So if you make a calculation, 20k divided by 512, this will go 2 times. I need 40 blocks. 40 blocks of the linked list are needed to store all 20k free disk block address. This itself simple can be a 5-mark question, please. So make an understanding of this. Again, I repeat summarizingly, free list approach means we are going to create a linked list having blocks, nodes as blocks of the disk, where blocks of the linked list will contain addresses of free blocks. So these are free block addresses. So how many blocks of the linked list are needed? How many nodes of the linked list are needed? So I can make a simple calculation. One block which is of size 1 KB can store 512 addresses. Why? Because block size is 1 KB, address is 2 bytes. So 512 addresses can be kept. We have got a total of 20k addresses. So how many blocks of the linked list are needed to store all these 20k blocks? That is the calculation. So all 20k blocks need 40 blocks. 20k divided by 512, 40. So it's a very simple calculation. Make an analysis of it. So this is the first approach of storing free disk block addresses. This is the first algorithm. Okay. Now let's proceed to next algorithm. The second approach of free list management or free block management is called Bitmap. Second algorithm is Bitmap, also called bit vector. So what is the ideology of this? Let me write it here. We are going to associate a bit, binary bit, with each block. We are going to associate a binary bit with each block. This bit can take two values, 0 or 1. 0 means block is free, 1 means block in use. This is the approach. So again I repeat, associated with every block we are going to have a binary bit, the bit indicating the status of the block. Whether block is free or block is in use. Now for example, I can create my bitmap for my disk. Come on, what is my disk? Disk has got how many blocks? 20k blocks. So per block I need a bit. Maybe the first bit of the first block is 1, means block is in use. Second bit is 1, in use, 0, 1, 0. Maybe I can have a bitmap something like this. What does this mean? It goes on. It goes on. This is my bitmap. This is my bitmap or bit vector. So what is this bitmap indicating? Let me show. This is the bit of the first block, bit of the second block, bit of the third block, fourth block, fifth block, sixth block, like that it goes. So this say that the first block is in use, second block is in use, third block is free, fourth block is in use, fifth block is free, and like that it goes. So that is bitmap. So bitmap is going to indicate the status of the block, whether it is in use or whether it is free. So this is the second approach of managing the free space. So that means if I want to allocate some free blocks to a file, I will have to search in the bitmap. Search in the bitmap where are the free blocks and accordingly allocate. Whereas in free list approach, if you want to allocate, I don't have to search. Remember that I don't have to search. Why? Because it is keeping track of only free blocks. Let us look back to the free list. Go back to the free list approach. Look at this. Free list is keeping track of all free blocks. So I don't have to search here. If I want to take 3 blocks, I will take 3 addresses from here, 4 addresses from here. Whatever number of blocks you want, you can allocate it. So like that it goes. So that is a free list. So in bitmap, we are keeping track of the disk blocks by means of bits, which are going to indicate the status of the block, whether block is in use or block is free. And accordingly, we can keep track of the blocks. Okay. All right. So these are the 2 approaches that I have presented to you. There is a third approach also. Let us discuss what is that third approach that indicates. Now before that, so comparatively, if you want to compare free list and bitmap, free list keeps track of free blocks, bitmap keeps track of all blocks. Free list hold addresses of only free blocks, bitmap store addresses of all blocks. Free list approach is more efficient for block allocation because I don't have to search for free blocks, whereas in bitmap we have to search for free blocks. So that is a relative comparison between these 2 approaches. This itself could be a 5-mark question for you, or maybe a 10-mark. Explain the different free space management algorithms, or you may be asked to compare free list and bitmap, and you can do that. Now the third approach of free space management is called counting method or counter method. I just write count, counter or counting, whatever you want, counter method. Now this approach is primarily deployed or used when most of the blocks are contiguously free. If majority of the blocks are contiguously free, then this approach is most reliable, most suitable. So how does it work? Let's see, counter method. Most of the blocks are contiguously free, or the blocks which are free are contiguous. So how do we keep track of it? Like what I'm saying, I'm going to maintain like a directory structure here to indicate this approach. Okay, so please follow. So what is the ideology behind this? So in the first column, I would say address of first free block, and count of free blocks. How many are free contiguous from there? Meaning, say for example, the address of first free block is 5, and from there 20 blocks are free. So that means starting from 5, 6, 7, 8 like that up to 20 are free, contiguously free. Got it? Like that I can have at another place, for example, starting from block number 55, 100 blocks are free. So starting from block number 55, 56, 57, so on, 100. These are all free. I hope now it is very clear. Now starting from 210, some 80 blocks are free. Like that it goes. So at different place of disk we keep track of what blocks are free by means of this approach. So later, if some file needs to get 15 blocks, so I can allocate from here or here or here, for which I can use policies like first fit, best fit, we have discussed this earlier, or maybe worst fit. First fit means I allocate from here. Best fit means I allocate from here. Worst fit means I allocate from 100, and like that it goes. So these are essentially the three approaches of managing the disk free space. Managing the disk free space. So one approach we discussed is free list. The second approach that we discussed was bitmap. Okay, remember that? This is a bitmap. So free list keeps track of only free blocks in the form of linked list. Bitmap keeps track of each block in the form of binary bit indicating the status of the block, and the counter method is primarily used when most of the blocks are contiguously free. We maintain a sort of directory information giving the information about where are the contiguous free blocks. So please practice this. Please remember this three methods. You can directly expect a 10-mark question or maybe a 5-mark question from this topic. So this is also an equally important. So these are the issues involved in the design of the file system. So these issues essentially are important from your examination perspective. Okay, so I basically advise you that you conceptualize this well. So here I am going to show you summarizingly what all the important issues in the design of the file system. So in the design of the file system, I want everybody to be well familiar with the layered file system structure, then partition structure. All these topics I have already discussed in my previous videos. So important topics I am telling from this unit: partition structure, then most important topic, allocation methods, wherein I have presented to you contiguous, linked, indexed, and based on index I have discussed Unix inode structure. And then after allocation methods, the last topic is free space management. Free space management algorithm, the one which are presented in this video. So what I wanted to tell you that if you make a study of all these topics thoroughly, then I am very sure you can be in a position to work out short questions as well as long questions very comfortably. So prepare this, and I am very sure you will be able to work out. So in addition to that, I am also going to share my PPTs. There are 2 PPTs based on this chapter, based on this unit. So both the PPTs you can follow in conformance with my videos. Of these 3 videos are there in this chapter or for this unit. So watch all the 3 videos, make yourself well comfortable. I am very sure you can be in a position to work out any question. Okay, right.